Hi, this is Aishwarya. I am currently working as an assistant professor at the Department of ECE at SNS College of Engineering. So today's topic is triangular wave generator. So in fact, this is the diagram for triangular wave generator. So now this diagram is consisting of two parts. So one is comparator, another one is integrator. So the first half is comparator. Second half is integrator. Second half is integrator. Okay. So the comparator output is square wave. The comparator output is square wave, and the integrator output is triangular wave. So how should you say this is a triangular wave? Means after this working process, we will get the triangular wave output here. Okay. So in this waveform generator, this is a triangular generator. So basically it will generate something. One type of wave. Okay. So this triangular wave generator having two parts, one is comparator, another one is integrator. So this comparator initially doesn't have any input signal here. Okay, there is no input signal here, so it will produce zero output here. Basically, a comparator means it compares the two input value and it will produce output as 0 or either 1. Okay, so that 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1. So it is known as a square wave output. Okay, so now the comparator output is 0. There is no output for initial stage. This 0 is given to the integrator circuit. So integrator start the integration process. In that process, this capacitor will discharge the value. So after that, this discharging signal is given to the circuit, the first block of circuit as an input. So now it will produce the output as 1. So again that signal is given to the integrator. So integrator is taken input from inverting terminal. So now the capacitor will charge the value. Then the output is high. So it will charge the output. So the output will be going to the rise time condition. Okay. Again the signal is given to the comparator. After that again it will produce 0, so that the comparator will discharge the previous charge signal. So again it will discharge the signal, so rise time will be found in the output. So this is the process. Based upon this comparator output, integrator will integrate the signal and capacitor will charge and discharge the signal, so that we will get the triangular wave output here. So this is the working process of this triangular wave generator. Okay. So this is the waveform for our triangular wave generator. So initially, this square wave is comparator output, the triangular wave is our integrator output. Correct. Okay. So this square wave is denoted as plus V sat and minus V saturation voltage, and this triangular wave output is considered as minus VRAM and plus VRAM signal. So now already discussed in previous diagram, right? So whenever I apply the signal to the comparator, it will produce the output, and that time integrator will produce the output as in the charging and discharging mode, so that the comparator will goes to high, so that the capacitor will discharge the signal here. Okay. Then the comparator goes to low, means the integrator will charge the value, so that we will get the integrator output as a triangular wave. Okay. So the triangular wave, let us find the frequency and amplitude of our triangular wave. Okay. So initially minus VRAM plus R2 by R2 plus R3, because we used only two resistors R2 and R3, and into plus V saturation minus V RAM. Okay, so in this condition mentioned the effective